All right. Hello again. This is Philip Steiger at thebest3d.com, and I am looking at the best 3D. This is from my friend Shlomi Malachi. Shlomi Malachi. I don't know how to pronounce your name, Shlomi. You're gonna have to educate me on that. Shlomi, Shalom Shlomi. What you see here is a 3D rendering of a famous castle, Schloss Neuschwanstein. And this is a project that Shlomi has been working on for many years, actually. What you see here is an image sequence, a couple of images that show the rendering from a changing camera position. You might see some other examples of some earlier renderings here at thebest3d.com/smart3d. And of course, SMART stands for Shlomi Malachi Art. Smart 3D, and there are some early versions of the models and the renderings and screen captures from quite a while ago, but the project is coming to beautiful completion, and it's probably never really completed, but there are some fabulous images now starting to be produced with that. And I wanted to show you some of here are some earlier versions when it started in Amapi. I'm happy. So, what we are doing now is starting to do some renderings with this. And we have some renderings such as this here, a sequence of images, and if I cycle from one image to the next, you can see there's quite a bit of movement. So this might be a little bit too fast for the motion prediction module, but we'll give that a try. We'll see, for instance, here we have 15 frames from here to about here until the camera changes direction. And then there's another 15 frames here, and then there's another 15. So every 15 frames, maybe even fewer than that, there seems to be a change in which way the camera is moving. And then we also have some animations we have produced from that. So what you can see in some cases, we actually have an animation now.
Right.
This one's screen capture. Let's go and launch Howler and actually render or load these renderings. Here's one that will show what we're going to try to do. This one's in QuickTime format now. I converted the output that came out from Howler as an AVI, and let me go to Control 2 to make it twice. So it's a very small dimension, so it's a bit blurry when you scale it up. But the goal really is just to see what you can do with the motion prediction module. Looking at down here where the trees are, you can see some nice continuity of the animation. And what we'll do is we'll try to recreate that in Project Waffle right now. So let's go to animation and load a sequence. And that sequence, let's see, where do we have that? It's on, I guess I should find it up here on my folder. Let's go into documents. There you go. And there is the best3d.com, and there is a smart 3D folder. One more. Oh, there it is. And 2014. And we're going down to the animation test. So here is an image sequence that was rendered out of Cinema 4D. You notice that, not out of Carrara for once, right? Carrara being my favorite 3D animation program. Cinema 4D is just one notch up above that, more professional perhaps, but you know, out of my league budget-wise. But this is what Shlomi is using, and so he's rendered a series of images, TIFF images. Let's do a quick test here and just select 5 or so and load that. Just to do a test to see if that works. Yep, there it is. So that loads quite nicely. And what we'll do is we'll now load the whole sequence. So let's go again to animation, load sequence. And actually not the whole, let's grab just about 15 frames or so, maybe a few more, and start with that. This one is going to be a very difficult one to work with actually, because the camera is moving a lot here. This is probably too much for the motion prediction module. There may be a bit of a challenge. And in fact, maybe we'll focus on just a sequence that starts from here, going to about here. Right? That one doesn't have too much lateral motion and topology changes in the image itself, which means that we should be able to actually do a fairly decent job at motion prediction or motion estimated interpolation. And so what we want to do is say cut a few of these frames out from here. Let's mark it with the in point and then set a marker marker just around here. And so this section we don't need anymore. Right click on that and delete this block, and then we start that way at this position, and then we move forward, and here we go. I think that's a good sequence. Now it's only 16 frames long. It's a very short sequence, and you know, if you play it, I don't care if you play it at 24 frames a second or 30 frames a second. Let's do that. You'll see it's going really fast, and just too fast to really enjoy. And in our presentation, maybe what we'd like to do is have it just go much slower. And let's first see what would happen if we use the traditional approach. Let's first store this, and so that way we can go back to this really quickly. This is a stored copy on disk. It doesn't take much memory and or RAM. What we'll do now is first use the traditional approach for right-clicking here on the timeline and doing the time stretch. When you do time stretch, you're basically adding some frames in between and blending them with the next ones, and you can do that a few times. Click on this here to go 4 or 5 times. But what's going to happen is that you will get a little bit of strobing. You see how it's blurry, and you can see how it's like a ghosting effect. Let's see, for instance, focus on this one here, the tower on the right side. And it's not surprising, because that's really the only thing it can do when you do motion, when you don't do motion-based interpolation, but simply frame or pixel-based. It's blending one frame out. See this one here? When you look at this part, oh, that's too big a brush. Let's go make the brush a little bit smaller. Right? If you look at this area here, and then you go to the next frame, there it is, and let's use the onion skin. You can, well, actually without it, you can see how the prior frames blend away. The next frame comes in shortly after that, and so it's doing this transition, and it's essentially giving you a bit of a headache, I would say. You know, it's a strobing effect. When you play it fast, it makes it look like there is a sneaky motion, or a snake, or a snail, or something like that. It's just something that you can't really avoid if you have if you do frame blending. You know, you have to blend the pixels in and then blend them back out over a couple of frames, and so that can be very disruptive. You look at the castle here on the left side, for instance. You can tell this is definitely not pretty to look at. So what we'll do is we'll try to avoid that by using the motion prediction module instead. With the motion estimation, what we'll do is we'll slice the image into a bunch of sub tiles like this, and then we'll try to see for each of those. We'll put a motion tracker on it, and we'll have kind of an analysis of that image in the neighborhood to see if for each of those, where did it move? You know, did it move this way, or did it move this way? Did it move this way? All of this is going to be allowing us to create, hopefully, a tiled replica, perhaps one that also blends, but certainly with potential to just be moving rather than fading away and coming back in. And as it moves, it doesn't have to fade away, it just stays, and it gives you a much cleaner transition on that animation. So that's sort of a technique to create super slow motion. Let's click here on the stored copy to restore it, and let's get right into the filters animated category and go to the motion prediction module. And so we have a total of 16 frames here. And what we'd like to do is first do some try run, just to try this a little bit and see what we get, and rip it. Perhaps scan for dropped frames. Don't need that necessarily. Let's just go, and there's going to be now 43 frames. So you see the number of tweens here is 3, and that went really quick. Too fast to tell whether it's really usable. So let's increase this to maybe 12. and now we have 169 frames. Looking better. We can tell now, we can focus a little bit on where there are some problem areas. You can see there's something in the Windows area here. Let me make it even more. Let me make it 33 tweens. So for that, now we get 463 frames. And if you look at the top of the roof here, like this area or this one, there is a little bit of a challenge there too, right? So check this one out. Yeah, there is a little bit too much motion on that, too much movement. And so what we'll need to do is see if perhaps we can either adjust the distance by which we look for it, or do some sort of a change in the tiling of that picture. This is showing how many motion trackers we have. Each square you see here is going to be equipped with a motion tracker, and the motion estimation algorithm will then take a look at seeing if it can determine which way they moved. So we can see, perhaps by changing these parameters. Now this one's still moving too fast. Now it's a little bit better. What we could do is perhaps use the fudge factor here too. Let's go down really low and see if that one helps a little bit. Yeah, so that there are some limits to what you can do with that. What you want to do is focus on the parts where it really works well, and then perhaps identify what we can do to work. There are some areas here which are repetitive patterns. See, this one here looks just exactly the same like this, or very much almost identical, and so it's difficult for the motion prediction module to really tell where it moved. Did it move from here to here, or did it move from here to here? And that's why it's getting a bit confused with some of the parts. If there are no duplicates or no identicals, then it's a little bit easier for it to figure out where to place it and where to move. All right, so at this point, let me do this again. Let me go and load the original here, and I'm going to go still dry run, and if we are exploring, trying to understand how that what the motion trackers are seeing, you can actually show the motion vectors, perhaps as an arrow, and let's give it still the same, and so you can see here which way it thinks the parts are moving based on your camera movement, right? So not surprisingly, we get sort of a general flow into the center or where the camera is heading, but there are some differences in some areas. There's some turbulence in the clouds. There are some parts around here where the clouds, where the balconies are, or where the windows are so similar, and we'll need to experiment with that a little bit to see if we can get it right to cover that as well. So let's try all the way down to the lowest resolution. That's probably not going to be it, but let's try that nonetheless. And then also, don't keep it at such a far distance. Each of those small elements is not going to move that far. So let's keep it relatively in reason here. And of course, that's going to take significantly more time to render. But sometimes that's where you need to go to get better results. Now you see some areas here still moving too fast, and that's really along the edge. All along the edge, you will not get to. You cannot expect it to do anything usable, because it doesn't know what's on the outside, what's beyond the limit of the universe, right? The universe it sees is this current image, and beyond that, it doesn't see or know what to make up out there. So it's going to it's probably not even going to try. What you can do though is you can reduce the size of the search area. Grid spacing might want to go up a little bit. Let's see if we can do that. And then also there's a refinement pass. Let's try this. So yeah, this is not too bad. It's still going to swim a little bit here, but maybe the idea is to then crop the portions that are not usable on the outside here on the edges, and just focus on the beautiful animation in the middle. So let's see if we can do that. Let's go render this now. Let's go actually do this. If it's a very noisy picture, which this one is not, there is no swimming or noise or video side effects and stuff. But if it were, instead of relying on just the one frame at a time, you could give it a stochastic average average of 5, 2 ahead, 2 before, beyond it, or before, and then the one right on it. And so that would take additional time, but would potentially give you additional quality. The other thing that you could do is also do some refinement, the optimizations on the refinement, and that's something I would do after you're done with the parameters to the point where I say, okay, that's good, I'm going to use it, but before you do final render, so you do the dry run. So let's do this. Let's actually do without the sampling, and see, we don't need the arrows anymore, or I mean the motion, this one here. Let's go and let it go through that. And now also do the refinement pass. And at that point we could render that, or we can still test it at this level and see if that's going to give us nirvana. So let's see. Yeah, but I think this is good enough for what we need. You know, many times in the end you actually don't need to keep it crisp. Sometimes you just need to make it blurry because you're going to have some titles that scroll on top of it in front. So let's go do just that. Let's go out of the dry run mode and go. And so we have 463 frames being rendered now, and then they're going to be inserted into the final animation. And it's never final really, but we're getting closer to it anyway. What we have now, let's go close this. We now have this animation. The first frame is actually a replica of the last one after the motion prediction module did its thing, so we can delete this one. And then we can see there's probably a few more we can delete, because you see a bit of turbulence here, perhaps here. When it's moving too fast, it's just beyond the scope but of the motion estimation capabilities. But if you look at this and perhaps zoom or crop into it, maybe what we can do is go to the image and crop tool and focus on about this area here and crop that. So it's going to crop on that section in the animation at that point. There you go. And we can go and store that animation now too. So to disk, and you'll if you do crop it, you know, be sure you test the dimensions of it too. Go to image info, because you might have cropped it to odd numbers. This one, Lucky Strike here at 476 is an even number, 278 is an even number, but maybe not the best one. Some codecs, if you save it to AVI, might not work with 278 pixels height. You might need to make it 280 or 276 or something like that. So, but if it were an odd number, for sure you want to change that. You could go to image and resample it, and maybe make it a little bit smaller or even bigger. Maybe you need this to be a bigger image now. So let's go. Let's in fact see what we get. Let's keep it constrained and make it 270, which is one of the HD formats. If we have like 480 by 270, and you see here we're shy. We're not exactly at 480. So you know, you might not notice the difference if you scale it up to 480 and then force it to 270 here at this level, right? Or if you multiply it by 2, now you have it multiply by 2, 960 by 540. That's a common dimension, half the width of what shall we call it, of a HD. We can actually go also to some of the presets that are nearby, like 640 by 360. There it is, the 360p. Let's use that. So it's going to sample the pictures up. Let's do the best quality by cubic. That's the default anyway, and okay that. So we have a slightly different size and aspect ratio. Not enough aspect ratio change. Not enough change on the aspect ratio to really make it look distorted. I mean, you'd have to really know your castle to to tell that there is something wrong with it here. Now we still have a little bit of swimming on the lower left here. We didn't crop enough, but that's just really one of the challenges with it. And maybe what we'll do really is kind of blur to the edge. So let's go and create a, first of all, let's store this one. This one's a good one to keep. Let's store to disk. And at this point, what we could add there to this is perhaps a little wooden frame around it. So I'm going to go to the image, frame your work, right? And framing my work basically is putting a wooden frame around it here on this current image, but actually then applies it over the entire animation as well. So I'm gonna go find me something like this. Let's see which one do I like the best here. I think that one's pretty neat. Let's add a little bit of let's see, inversion to the frame. Yeah, let's do this. Texture, let's add some wood grain. Let's make it a little bit bigger. The matte size, the matte 2, the white and the gray ones are good, but we can make the frame size a little bit bigger. Let's make it, let's add 100 in front of that, so 180 total. Let's click on this here and add 1. So we have 180, and inverting the frame. So now this is good. I like this. This is adding a nice solid wooden texture to it, and perhaps some foam core and paper texture also. So we can add some paper texture intensity at 44, something like that. So the paper texture is going to be, I think, on the gray part, the gray foam core, or the gray matte. All right, now when you do this, be careful. This might cause you to run out of memory if you have an image that's just too big, or if you have an animation that's too big. So it's going to allocate a lot of memory here. With any luck, we are still in round for this, and we should see very soon. Yep, there it is. All right, so we have the frame. The animation is still good. The system now allocated memory all around it to place the frame there, but it actually only placed it on the first one, the first image. So what you can do though is you can go to, let's say you can go to the next frames, like this one here, and select the black outline, right? And then you have basically the selection that you really should consider is the selection also for the frame all around it. Right, so let's go here and select with the magic wand. That's the easiest way to do it. Just click here, and you now have selected the area around it, and you can go back to the first frame and just pick this up as a custom brush. Right, so you can, well, first of all, you might want to store it. Let's go store a copy here, and that actually stores it with the alpha channel, which is a good way to use it if you then want to just copy that into the swap image. You could go and store, where is it there? Copy to swap image on the first frame. There you go. Now you can also store the alpha. If you look at selection, store alpha, you see indeed it has just the white area around it where the wooden frame is. The picture on the inside is not selected. So one thing you can do, if we switch to the swap image, we don't see a difference here, but we can actually erase the part that's in the middle here and erase that to black. Now right now we have the outside part selected, so let's go and invert the selection, invert and replace it. So now we have the inner part selected. Let's go erase that, right click here and erase to black. So we now have a picture of just the wooden frame and nothing on the inside. We could perhaps add a little bit of lighting to that. Let's see if we add the filter. Let's get rid of the selection here. We need to perhaps invert the selection again. There you go. Replace. So we have the outer part now, the wooden frame selected, everything really. And let's go to, let's see, store this one, store this image, store image copy. There you go. So we have a nice safe copy of the wooden frame by itself. And again, we could make this a custom brush and then just paint it across the entire sequence here. Another technique would be to actually load that image into the swap image. So let's go do just that, load this to copy it to the swap image. There you go. And then actually, wait, we were looking at the swap already, so let's undo that and simply switch back to the main image. And so now we're looking at the main image, as you see here, and we probably should place this original image back in there. There you go. The swap image, as you can see, contains this. Let's switch back to the main image and combine the two together. Right, this is just a matter of now combining the two. Perhaps we can do that across the entire animation. And what you could do, for instance, is through the alpha channel, of course. So with the alpha channel being selected on the outside, it's only going to copy over what's from the swap buffer in this area around it, so that for all of these frames, the animation we see here is not going to be replaced. It's going to actually show us the actual animation going through there, while the wooden frame is being pulled in from the swap image. That's really what we're trying to do here. So let's go do that simply by using the for instance the right click here and doing a combination of the two. Could be, or actually let's do a filter combined with swap. There you go, and then mix the two buffers. All right, so with that you can say how much you want. Now the two images on the first frame are actually identical, so you won't see much of a difference there. What you'll need to do is perhaps switch over to a different one, or perhaps use the timeline where you can even keyframe it and add a little bit of additional pizzazz, you know, and see the first one perhaps go, where is it, combine, there, combine mix buffer. There you go. So now you can see you can combine the two, and but it's combining it through the alpha channel, meaning if for instance you go to about halfway here and you scrub through it, the animation that's on the inside is not being replaced because the alpha channel says, hold on, hands off, don't change that, right? So the outside is being blended in from the as you see here in the preview, the outside is being blended in from the swap image, but the inside is being left alone, and it shows the original that's in the main image. So you just make it go to mix buffer at 100% or 255, and then that way you get a perfect match of the two together, courtesy of the alpha channel. Now if you wanted to add a little bit of pizzazz, you can make it even do a little bit of a transition. So you start with this at 0. Now the first frame, as I mentioned, already has the frame, so no surprise there. We could actually erase that. Let's see, yeah, we can right click here on this and erase to black, and just the selection will be erased, and there you go. So now all of the frames are showing no wooden frame there. It is, however, in the background. And so let's go to the first frame there and perhaps add a little bit more on this window size here so we can see more detail. And let's go to keyframe that, and then perhaps all the way here through this animation, about this far, 1/3 into the animation, we'll keep it as is, and now we'll start increasing this parameter with the mix buffer. About this much into it, we'll want the wooden frame to be showing completely. All right, so add another keyframe there and stay there. All right, so we can keep that one there too and keyframe it all the way to the end if we want to. And so we have a little transition here where the animation continues, but in between we start without a frame, and then we show the frame. And you can here adjust how many frames you want to dedicate to that transition, and also if you want that transition to be a straight line, linear transition, as you see here, or sort of a spline interpolation, which may cause it to undershoot or overshoot if it goes really fast. So it might actually be better in this case to go just linear. There you go. All right, so let's go and render that. Let's go and make sure that you have the save undo here as well. Let's go and apply this. And so now we have this animation where the wooden frame is gradually appearing. And of course we could have done a little bit of more lighting to that, perhaps draw, do a little bit of lighting on the wooden frame so that it appears to be lit by a light source, like a spotlight above it. We can still do that later, or we can just redo it. But let's go and store this animation. This is a good one to keep, so let's store to disk. And at this point we're pretty much done. Let's go and review the final animation as soon as it's ready for inspection.